Welcome back to the stream, folks. It is Monday afternoon here, and we are continuing work on the Tuco Flyer project. There he is. That's the star of the show. Tuco Flyer is, of course, the robot that is named after this critter down here, Tuco the cat. This camera is Tuco Tripod, which is the non-flying version of Tuco Flyer. Basically, the goal here is to make it a little easier to follow the cat around during streams, and then to also give people a really neat interactive way to hang out with my cat 24/7 on Twitch. Or at least close to 24/7. I might want some privacy limits, but you know, for the most part, cat and internet interactivity via robots seems like a positive thing to facilitate when I can allow it. So yeah, that's pretty much what's going on here. I've been working on making a camera that can fly around on cords, in this case paracord pulled up by 4 spool robots. The camera itself is on a gimbal that's currently kind of a weird modified quadcopter gimbal that's got kind of a weird modified closed circuit television camera mounted on it. And so most of the stream actually is going to be doing some work on reverse engineering / fixing the gimbal. I, around the same time, figured out the protocol for communicating with the gimbal and changing its parameters, and also pretty much simultaneously realized that I just wrecked a whole bunch of the parameters on this gimbal. That's a nice tip from Mike Matisse in the chat, who says if you leave beam.com up, and by that I think he means the site, if you go to the page beam.com/scanlime, that's simulcast. I'm sending the video there and YouTube. So if you have problems with YouTube, there's a backup stream. And apparently if you leave that beam.com, or I think it's beam.pro actually, but maybe there's beam.com also. Yeah, beam.something or other. If you leave that page up, then I guess it will just keep, or it'll just automatically restart the stream. I think Twitch does that too. Robert in chat is saying that they still want to see the gimbal firmware. Well, you know, if you'd like to buy one of these gimbals and try some destructive experiments yourself, then that's cool. Over here, I'm interested in seeing the firmware, and if it comes to that, I would certainly love to dig in, but my primary goal here is to make a cat robot. So once I finish that, if I still have a spare gimbal that works, then I might use that to try to do a more difficult firmware extraction technique. But right now, the firmware extraction is secondary to the lovable cat internet interactions, so just trying to keep some perspective here. But if you would love to play along at home, then I encourage you to. The model of gimbal we've been experimenting on is by Feiyu Tech, and it's the Mini, what is this called? The Mini 3D. There exists a Mini 3D Pro, which I think is slightly different, so we've been focusing just on the plain old Mini 3D model. This cat's holding remarkably still. Part of the reason for less streaming recently is that my friend who is moving away off to the East Coast was spending his last week here staying with me because he had already gotten rid of his previous housing, and I was also helping him with packing and stuff, and also just kind of wanted to spend time with him since I'm not going to get to see him for a while. But now it's just me and Tuco, and we can do some electronics. And Tuco's over here, out of frame. Oh yeah, if anybody would like to support Robert in an effort to extract firmware from a gimbal, then maybe you should get in touch with them to to supply them with the gimbal, because I think that might be the limiting factor here, is that I have 2 gimbals here, which is great. I've got one that's definitely modified for the purposes of this robot, and one that's my spare, which so far I've been using just to get clean parameters from, and that one was graciously provided by Mark in chat. So, and Tuco is kind of asking for something now. Tuco, what's going on? But yeah, I don't quite have an excess of gimbals here to the point where I want to try to do firmware extraction techniques on them right now. I think if I do end up with a spare gimbal, then this might be the kind of thing that can do an auxiliary camera, like maybe the thermal camera could use a gimbal. Maybe this is powerful enough to do some kind of bolt launcher gimbal. Two goes hanging out in the mess. Okay, I think we can leave it be. So most of this I wanted to focus on actually getting back into working on the gimbal. So this is our pretty heavily modified gimbal from, this is the Feiyu Tech Mini. We've seen this before, but let me grab the, oh, actually I've got the box right here. This is a pretty good illustration of what it's supposed to look like. My monitor just went black. What even just happened? I think there's a flaky HDMI cable over here in the part of the setup that I still haven't really gotten settled down yet. Oh. Well, I've got a cat at my feet, and now my video's back. Hey, Tuco. Yeah, you don't want any of that, do you? All right. This is the gimbal we've been using. Suitable for aircraft, also for cat robots, I hope. So it's a little thing that's 3-axis and actually pretty well made. In the photo here, which you'll see this photo on a lot of retailers that are selling these apparently, in the photo it looks like these elbow housings here are made of plastic, but they're actually really nice machined aluminum, so I've been pretty happy with the mechanical aspects of this. Each joint has its own microcontroller, its own power supply, its own magnetic angle encoder, so it's actually a pretty nice design. And we've been learning a lot about how the protocol works. Each joint has a separate microcontroller. They all communicate with each other over a serial bus that goes at 2 megabits, if I remember right. And it's basically the same protocol that we're seeing externally on the 115 kilobit serial bus that we have exposed for configuration and, we hope, external control. And so this is a gimbal that normally takes pulse width modulations in from an RC aircraft receiver, but there's a configuration mode you can get it into where you can interrupt it during startup, and instead of going into that pulse width modulation mode, it goes into a mode where it's continuing to allow bidirectional serial communication at 115 kbaud over the pins that would usually be PWM coming in. We're catching up on chat. Oh, that's interesting. Are people having audio sync problems? I realized that I haven't actually restarted OBS in a little while, and sometimes if I don't restart it, it loses sync. But I might also just need to give it another round of calibration. I guess what I'm saying is the audio issues could totally be on my end, but it would be nice to have a confirmation. Okay, wow. Okay, it looks like the audio is pretty badly off. The only way I know of to fix that reliably is to restart OBS, which means there will be a minor break in the stream, but I will be right back. So I think that's what's gonna happen. I'll be right back, people. And all right, trying to hot swap instances of OBS here. Let's see if YouTube keeps this continuous. Things have gotten a little more complicated since the streaming machine now has 2 instances of OBS running on it. Let me know if that's an improvement. I think this just might have restarted or resynchronized the sound, but let me know if there's still a problem here. Hey, Duke. Okay, cool. I think that was the problem. I think there's just some kind of cumulative delay in OBS Studio, so if I leave that thing open, even if it's not streaming, and then just start streaming, then the delay has added up. Like there's a buffer somewhere that just doesn't know how to empty or resynchronize itself. So that seems like a bug that someone motivated enough could go track down. But I think I might leave debugging that for another day and just try to remember to restart OBS before streaming. So, wow, this cat wants to play. Did you not like that one, Tuco? I think that's better. So basically the whole goal of the project is to have better cinematography during moments like this. So I think it might need to have some combination of computer vision and command-based tracking in Twitch. Because, I can imagine starting this out for sure with this thing that we've been planning on where you just kind of tell, the robot like up, down, left, right in chat. But I imagine it's going to be a lot more fun at first to fly it with the Xbox controller. And I think it'll be interesting to try to find ways to have maybe a little bit of algorithmic assistance to make the command interface feel as fun as possible, even if you have some latency between you and the robot. Yeah, Twitch Plays Cat is pretty much my goal. I feel like it'll take a lot of stuff to get there. Like, I've barely even thought about bolt thrower designs that'll really stand up to Tuco's demands. It's like I've got some prototypes of a thing that'll fling bolts, but it's not even really that good at giving them a consistently powerful throw. And really, I think Tuco needs a little bit of tantalizing attention with the bolt before it lets go across the room. I think really the best experiences for Tuco are when he sees the bolt kind of like skitter and scrape across the floor a little bit and then just suddenly take off. I think he really likes that. So I think it'll be interesting to experiment with machines that can try to replicate that with input from Twitch. Hey Tuco, do you just like that box? Are you into boxes right now? I think, surprise, surprise, Tuco is into boxes right now. Oh yeah, Robert is saying it needs anarchy/democracy mode. Yeah, that would be interesting. So yeah, we've already got a little bit of progress on the software for that. I haven't really been doing much myself on the like kind of bot or social side of that, but I think their name is Morix. I think they also go by Skila in chat, but they've been working on some kind of bot integration. And there's a little bit of that in the GitHub repository right now, so yeah. Oh yeah, there's a vote for petting the cat from Egg Robin. That's a good idea. I can do that. unless we have any objections. Here's its a little fuzzin'. Here's such a fuzzy little fuzzin'. I think he likes it. Hey, buddy. Yeah. I think that worked. All right, let's see. Let's keep Tuco in frame. And I wanted to, before we get deep into doing more gimbal work, I wanted to look at this piece that just finished 3D printing and do a little bit of testing on it. So, actually, we can take a look at CAD really quick. This is the crazy complicated CAD model that we've been building. Well, that I've done a lot of this off stream, but we've seen parts of this. A lot of the stream has been kind of slow going because I'm also learning a new tool here and learning how to think in Fusion 360 language for this design. Learning all the different ways I can screw up the joint and constraint relationships between parts. Learning all the terrible things I can do with the timeline and components. But anyway, these are the internal parts. The main spool. There's several different idlers here. It's potentially more complicated than it needs to be. I still don't know if these two pieces need to be separate. But the goal with this is that this is a measurement capstan it's supposed to turn the same amount as how much the cord moves through this whole mechanism. And so to accomplish that, there's a kind of controlled amount of tension that we put against the capstan using these two idlers. And then this load cell here also measures the tension perpendicular to it, so between this and the ceiling pulley. This idler here mostly just exists to keep the tension and the alignment constant going into this capstan. And then this idler exists to try to keep the cord centered on the, even though this angle is going to vary, but I want to kind of give the cord a way to get lined up even as the angle on the spool is wobbling side to side. I want it to be lined up nice and planar before it goes into this mechanism. So that was the thinking behind that. And then we 3D printed this piece before, which is way up here. The core, this plastic part, looks like that if I turn off all the internal stuff. It's got mounts for all the stuff that we were just seeing. When I turn that on, this is the main kind of load-bearing assembly. So this is partially put together. We were doing some testing on this yesterday. Then this is the piece that just finished 3D printing. So it's largely just kind of an aesthetic and safety shell that protects the moving parts here, but it also has the job of holding this axle and basically holding this against compression force going up mostly. So that's why there's kind of this triangular assembly, so that this whole plane with these kind of reinforcement ribs, its aim is to transmit the force up into these bolts that mount into these shafts here. I'm not entirely sure this assembly is going to be strong enough in the right places, but it seemed to be the best design I could come up with given the constraints, because there's a lot of places where I can't really add more reinforcement here because there isn't room. So I wanted to try this since it was one of the least, certain parts of the design. But I think the print came out all right. Oh, Tuco's going back on the rack. Robert asks if Tuco likes catnip. Yeah, he does. He seems to vary, sometimes he's kind of into it, sometimes he's less into it. I think he's less into catnip in general than he is into the bolt, but he does like it occasionally. I don't usually have a regular ritual where oh, it's Friday, it's catnip night, but yeah, I should try giving him some, and I'm sure he would appreciate it. He had an incline thing that had some catnip in it. Well, I'm sure it still has some catnip in it, but he just destroys that cardboard stuff pretty quickly. He's quite a little tiger. All right, so this is the piece we got. We switch back to this camera. Ta-da! And here's the one I printed earlier. I like this color. Let's get a slightly wider view. Alright, so I have done only very minimal cleanup on this print. You can see that there's still some support material I've got to get out of here. But the basic idea behind this is most of this is just a constant 2mm thick shell. So it's somewhat structural, but also just, kind of keeping the moving parts away from cats and humans, and hopefully providing some sound dampening. I hope this doesn't resonate more than it absorbs sound, but we'll see. Might need to add sound damping here and there. Mostly I want to see how good of a job this does holding the spool, and if it just makes the whole thing vibrate and wobble as the spool turns. So the test that I want to do today is just put these 3 bolts in, put the mechanical parts on, and then just power up the motor and see how it sounds, and look out for how much awful wobbling there is, and hopefully it's fine. If it isn't fine, I'll need to go back to the drawing board a little bit, which I won't do right away, but I'll be starting to think about. There's some support material deep in there. Should get that out with a screwdriver. I didn't need much support for this, but there's some support here where the bolt heads needed a rest, and it printed in this orientation. So that's what this support material is. These are M6. I think this one is M6 by 20, and these are M6 by 40. You can see the translucency. Look at my fingers in there. It's pretty cool. If there are any bright LEDs on the circuitry in here, you might actually see shadows on the inside case, but I don't think that's going to be the case. There are some green LEDs on the eval kit board, I think. If they're a problem, I can always disconnect them, but I don't think they're pointed directly out. I think they would end up being pointed in toward the mechanism. So they might cast some weird shadows, but I don't think they're bright enough to get through all the stuff in between. Okay, that's as cleaned up as this needs to be to test it. I don't need to make this totally aesthetically awesome yet. So we have outside surface, or we can put the bolt heads in. So this is just a captive bolt and nut that acts to, I didn't want... This is mostly in thinking about how to make this easy to assemble. If you can imagine putting this together, the motor goes in this side of the spool, and there's a set screw holding it in. Then in the very center, there's a bearing. And so I want an axle holding the bearing. And the way I chose to retain that was to have an M6 bolt that goes through there and is held on with a nut. And then this whole thing ends up acting as the center retainer for that bearing. So I'm gonna see if that works. M2 or M6 by 20. Which wrench do I use? This is a job for the yellow wrench. I think Tuco's having a relaxed time up there. Alright, let's get the nut in place. Where's my nut? I want something like that. Oops. Except more in frame. Always edit out the out of frame parts. Okay, this one should be pretty snug. Not so much that it's going to crack the PLA. Just enough that it's not resting only on the, like, a part of the bolt hole that's threading itself. I think that looks right. So that'll snug right up against the bearing. The way this is designed, that nut should come right up against the center of the bearing, but not touch the outer race of the bearing. And then the M6 bolt will actually hold it somewhat. Why would I need lock nuts for this? The plastic is making a pretty nice lock with the compression. And some M6 by 40s in there. Alright, so these, again, this is not really a clearance hole. I probably should have made these a little wider, but it's fine. Oh, this one needs a larger wrench. Oh, these Wearer wrenches are amazing. Alright, let's get these started, and then we have to attach it to the other part of the case. I don't understand what the point of this comment was from Robert. Oh, focus. Is this a good time to go into manual focus here? don't know what is making the autofocus work so badly today. There we go. So we want to have those in so that they're pretty much flush with the surface there. And that seems to be going in pretty straight. This one printed without any event. You can see I haven't really cleaned off the brim and support residue from the edge yet, but the print actually went pretty well. Alright, so far so good. Let's get the nuts in the other side. And this would be the time to put some paracord on if we wanted to test it threaded, but I think I want to test it non-threaded. Oh. Tuco and I both looked up at the noise that the roofers are at it again. So, this attaches via here and here. So we've already got a nut on this side actually because it had to go in behind the motor. On this side we're just going to put a nut in, and I actually want both of these to be captive nuts. So, and this is a prototype, so it's kind of bordering on silly to attach this to permanently. I was about to put some super glue on it and just say that like it would be pretty easy to crack the super glue, but I think it might be a little easier at this stage of prototyping to use a little bit of blue tack, this kind of squishy stuff. This is actually pretty handy stuff. People use it, like I think it's sold as like for putting posters on the wall, and that's what I always used it for as a kid. But then I saw people using it as a replacement for like a helping hands object for soldering, like those little alligator clip things. And actually it works really well for that, especially for oddly shaped parts that you want to keep in position. And it seems like a little bit of that might help these nuts stay in the right place, just for this prototype. This might be a terrible idea, but let's try it. So the nuts are in there. This is ready to have a temporary cover put on it. Let's see if any of it lines up. So we should right away feel the bearing fit into that piece there. So far so good. That feels pretty well. It does not look straight, does it? I think this means that I need to adjust the set screw on the spool to give me more clearance. It doesn't look like there's it's not nearly wide enough. So there is some adjustment there. I think this is a job for the lime green wrench. Okay. Andrew has a citation for locking nuts, I assume. Okay, so here's actually the way to line this up. And this would have been helpful to do before the test in the previous video. I didn't actually think to do this alignment, but the way that this is supposed to be set is so that the very center of the spool, you can see the thinnest point in the center, should be in the same plane as all of the pulleys up here. So, we might adjust it to get the proper fit with the bearing on the other side, but I think this is closer. I'm going to tighten this down and we'll see how the cover fits on. And that's just a set screw with a nut that slides in perpendicular. closer, actually. It looks like this might be just right. It might be a little bit... This is not flat, but I mean, I don't know where exactly the wobble is coming from. As I'm looking at it, I think that the core and the shell are lined up about right, which would mean that maybe the distance is good, but the actual spool has a bunch of warp to it, which I think is... Some of that might be the motor not sitting flat on the core, which is certainly a problem with this current core design. And some of that might be related to the set screw applying pressure unevenly. Might have to go to a design with multiple set screws. But I think we can tighten those two M6 bolts now. Yeah, the colors are interesting. I don't know how much of this is going to be retained into the final design or how much it matters, because, I mean, the exterior pieces I think are going to be all the same color. I was kind of into that stripey design that I'd been doing for a while in CAD, but no, that is not quite lined up. But then I ended up changing the mechanical design to be less complicated and to only have two exterior pieces, and it didn't seem like having a color boundary on the seam made sense anymore. So then it just seemed like I was down to just a single color 3D printed piece. But I could always decorate the outside with like stickers or vinyl, or I could even just make the winch bots, like all four of them, different colors if I wanted. I don't know. Or I could just make them boring, because the winch bots don't need to be exciting. It would have been nice to have wider clearance holes here so that I was only threading into the nut and not into the plastic. That is something to update the design with, wherever I can, maybe. But I do want to not have a lot of slack around the bolts, because the bolts, like the interface between the bolts and the plastic, are pretty structural. I want that to spread out the load as much as I can feasibly. So, that's with one bolt in. That bearing feels like it's being supported all right. That's not bad. And if I look under this blue tack, I should be able to see how far the bolt is versus how far I designed it to go in. Oh, it's not nearly in, actually. That was still feeling it thread into the plastic. Yeah, definitely wider clearance would be nice. I could also just ream that out with a drill, because like precise 3D printed bolt holes that are also structural does not seem like something I should be relying on. So either just dealing with having it be tight like this, or using some post-machining step might be the best approach. And honestly, having it be tight like this might not be bad, it's just a little annoying for the assembly. Let's see if I can actually set this down and get a better angle on all this. Let's maybe also start putting this one in. So I don't want this to be super annoying to take apart, since I will have to take this cover apart anytime there's a severe tangle or anytime I need to rethread the cord for some reason, but you know, I would also hope that those aren't things I would need to do super often. I don't have to take this cover off at all to mess with the electronics or the firmware. It's totally separated so that this side is the mechanical stuff and the other side is the electronic stuff. Paul is asking, could I add some features to the 3D printed parts to help guide the cover onto the core? Yeah, I could. There are parts that line up the two covers with each other, So if I have one of the covers on, then I can line the other cover up to the one that's already mounted, which is, I guess, the way I imagined doing this. It's not really that hard to line this up. It's mostly just annoying that these holes don't really give good clearance. Oh, okay, that screws in. So you can see I designed these to come pretty much to the end of the nut. So make sure that's snug. Yeah. And then this one. This one's got maybe 6 more turns to go. Should just grab this by the motor. That's probably the sturdiest place to grab it right now. I mean, it'll mount by an M8 bolt going through the middle, but I don't have those right now, so. But otherwise, that would be a convenient place to grab it. Okay, I think that's right. I think that's the right amount of tension. That's actually looking all right. So basically, this is now forming a U-shaped support around the spool, with one side being kind of doubling as the exterior face, and the other side doubling as the support core for the mechanical components. Let's restart this camera, and then maybe get a better wide-angle view. And then I'm just going to power this on and see if it shimmies awfully. So, got the big old 24-volt motor, got the spool, got a lot of mechanical stuff behind that cover where nobody can stick their fingers into it. And, oh, I think this could use a little more tightening. There's a, oh, maybe not. Maybe I'm flexing something. Already discovering a place where pushing on this makes it creak a little, but I think that's just this case piece pushing up against this core piece, which having that be close is kind of necessary. The other piece, like this interface, is actually where a lot of the force gets transmitted back to the mounting bracket, and so the other shell is going to come right up to here too. So this interface is actually going to be one of the parts that I'm a little worried about, but I took some care to design it, but there's certainly plenty of opportunity for it to be messed up still. Yeah, that's what we got so far. I think I'm going to put some power on this motor. Now it's at least easier to turn this on without it gashing another hole in my desk anti-static mat thing. So these are the load cell wires. These are the force sensor that's on this pulley. And this is the optical sensor that tells us how far the cord is moving. So these two sensors together give us, you know, velocity, acceleration, force, everything that I think we care about measuring right here. And then this is our power center. This is where we just pump energy into this to move the robot back and forth. So this motor is actually 24 volts, and we would normally be running this off of probably a beefy switching power supply and a little H-bridge. The power supply I have handy right here only goes up to 15 volts. But I think we'll only need to test this thing at, you know, partial speed. I don't think we'll need to worry about running this thing at full blast just to see if it shimmies. Let's maybe get the power supply back in there. Oh yeah. It's an interesting question, like what do you call this kind of collection of robots that we've created, and how useful are the individual robots? Yeah, I've been, like, the winchbot on its own wouldn't really do much, but I've been curious how reusable this would be for other projects. It kind of reminds me of Mechaduino, where, you know, that's like an add-on for a motor that turns it into something that's a much higher level component. And I'm wondering if this thing where it's just like a one-dimensional cord-moving robot with some feedback and Ethernet, like if that would be a useful component for other people. Okay, I've just got like 6 volts on the power supply right now. Ha 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 ha. Okay, so there are a couple of problems here. Can you see the entire top of the case rocking? I was a little worried that it would do that. But, like, it seems to be supporting that all right. My worry is that that will cause the interface between the two halves to creak or come undone. Once the other half is on, it might help support this, but, like, the fundamental problem is that this is just a super wobbly interface right now. I think some of that is the motor and the core not being mounted flat. So I need to redesign this so that the motor mounts in the flattest way I can. So like the top of the gearbox should go flush against something that was printed on the build surface. I shouldn't have this cut out. I need to give it much more space for the motor body here so that this doesn't interfere. The interference between the motor body and the undersized cutout I made here is why this is off planar. But then there's also a good bit of wobble just in the set screw joint, and I think that might just need some adjusting. Or maybe I should try this with less set screw tension and letting the bearing take more of the force there. Let's see how bad it gets if I run up the speed a little bit. Let me set this. Can I move this back at all? Yeah, I'm starting to like that idea of having maybe a second core piece and then having the shells be just shells, but this is... It also might just be fine if the spool wasn't wobbling so badly. Alright, this is like almost 16 volts. That makes it more obvious what's going on. It looks kind of cute though. It's like, I'm trying. Come on. Like pedaling uphill. Yeah, I think a lot of that is just the shaft. Let me see if I can fix that. So, can I get a wrench in there? Am I going to have to take this whole thing off? I think I have to take the cover off. Microhex says, gotta love that grinding noise. Yeah. Yeah. Let's do something else, not grinding. Yeah, if this was more of a clearance hole, it would only take a little bit of turning to get this off instead of a bunch of turning. But that would also mean the screw wouldn't actually be holding as much load. Like, I don't want to create a stress concentration in the plastic. I want to like distribute the load directly to as much of the screw as I can, which seems to imply the screw should have a pretty tight fit. So I think my lesson here so far is that this idea might work, but it definitely, like, I can't get away with a bunch of wobble. Like, it's gonna amplify, well, not, I don't know about amplify, but at least transmit the wobble instead of hiding it. Does this ever stop? These screws are so long. Man, M6x40 is serious. That M8x150 that I'm going to need for the horizontal support is sure is going to be something. Yeah, Lavender is suggesting cutouts for like adjusting the set screw. Yeah, I thought about doing that. It would be a bit of an aesthetic, like, it would be one of very few warts on the front of this. But, yeah, no, it might be necessary. I would just like to not have to adjust this a whole bunch. So... Let's see if I can, like, maybe leave the set screw loose and see how responsive it is to centering while it's running. I don't know. Like, it would be really nice if I could, like, set this in there at the right height and then tighten the set screw. That would have been smart. But there's also just a bunch of room for wobble in that joint. Maybe the thing is I just don't tighten this very far. Like, is that a thing that's valid here? Because I want that to, you know, I want that to make a good interface with the motor, but I don't want it to bind. I kind of feel like maybe what I really wanted was a set screw on either side. Let's see if that's any better. I don't know if I changed it that much, but I'm just gonna sit that there. That looks terrible. Why is it so bad? Not all of that's the motor being at the wrong angle. A lot of that is the joint. I wonder what it does if I just sit it on there without tightening the set screw at all. I mean, I think it's probably just going to scrape on that front surface. I wonder if there's something I can do to avoid that. And how much of this angle freedom goes away as I tighten the screw, I wonder. this into that position. I think that wobbles in the motor. I might need to decouple the motor from this a little more, or maybe I just need to deal with this. I think the motor shaft is not actually that straight. Let me get a better view. Let's turn the speed down at first. So if you look at the center of that motor shaft, you might already see what I'm talking about. That just looks like it's bent. So one question I have is, did it come like this, or did I do this in my experimentation so far? Let's grab another motor and see if it has the same problem. That's a lot better. Wow, well, that's not a good sign. Maybe let me sample one more of these motors and see if it varies at all. Yeah, this might require maybe a more flexible coupling between the motor and the spool than I had envisioned originally. Yeah, let me grab another one of these motors. freshly packed, as you can see. Yeah, this is going to require some changes to the design because I'm going to need a much sturdier mount for the spool and then some more serious decoupling between the spool and the motor. This will require some more time in CAD. This one seems alright. Maybe I just broke the other one via pulling on it a little bit. Yeah, star coupler. That sounds useful. Well, the bright side is I might be able to simplify other parts of the design. Like, I think I might be able to remove one of the two idlers at least. I don't know. Oh, Peter's suggesting to check how much I can actually manipulate the shaft with my hand. I mean, I think the issue here is that there just isn't much of a mount on the back side of this. I mean, I could try just mounting one of my spools to this. Light snug on the set screw. That's a lot better. Jared's asking if I've opened up the gearbox. I have not. That seems like a very messy proposition. We could do it if we need to. I'd rather not, just for the fun of it, because it doesn't seem fun. I mean, it's also possible I just had a bad motor, or I damaged that one some other way. Jarrett suggests it might be a useful autopsy. Well, do I have one to spare? I think I bought 5 of these. So these 2 should be working. And I have 2 more of these still wrapped up, which is 4. Enough for 4 winch bots. I could also order more of these if I have to. I'd prefer not to, though. So, I mean, I could take this apart somehow. I also wonder if this is something I did via trying to mount it in this plate that didn't really quite have enough room for it. Paul is suggesting that they'd be surprised if I could bend the shaft in such a sturdy motor with just the testing I've been doing so far, and suggests it might have been bent during shipping. Maybe. It would just really be nice to not have to depend on this quite so much. And I feel like this design is maybe close. I mean, I don't know, having the other side supported by this shell is probably not going to work out super well. As much as I thought that was a nice idea at the time, this is probably going to end badly. But I think that's probably enough testing this for now. If anybody out there has mechanical suggestions, I'd be all ears, but I'm also just going to keep working on this in CAD on my own. Might stream some of it, but I'll probably just do a lot of it here. I think the next thing to do here is probably to dig back into the gimbal parameters, because I'd really like to get this gimbal usable, and I think I've got a plan for that right now. Yeah, there's some things I like about this design, but certainly some things to dislike about it too. I kind of want to see if this works. If it works better with the with one of the less wobbly motors, but I'm a little worried that the mounting plate here was contributing to the motor's wobbliness, so I don't think I'm going to do that test quite yet. So I'm just going to put this aside and we can switch gears. SiteMasterDK in the YouTube chat is saying that I need a foot controller to control the camera. Actually, I've been thinking about setting up a foot controller. Probably, I mean, I'm not quite sure what kind of control you were talking about, but I could really use a better way of marking things in the recordings for making editing easier later on. The easiest way I thought of to do that was to have a little MIDI foot controller that would generate a beep that goes into my synchronization track. There's our gimbal. So for anyone who's just tuning into this gimbal saga, this is a Feiyu gimbal that I've been modifying to work with this kind of robot tracking, internet-controlled flyer, or sort of cat tracking robot contraption. Basically that consists of changing the camera out. So this is designed to work with a GoPro. I actually want this to work with a camera that has maybe a little bit nicer kind of telephoto lens, but the main difference here is that this has an SDI video output, which is something that I can easily get out to a stream without a bunch of additional latency or artifacting. I can send it directly out through a coax cable. And I also added, as you can see, this LiDAR rangefinder sensor, which will help it get to the right distance to be in focus. George suggests, don't you think the motor shaft is too short for the spool? Well, I mean, you could get a motor with a longer shaft, and that would be useful, but I don't know where you would find that. You'd probably have to have it custom made, or there aren't, I don't have a whole lot of choice in the motors. The motors I have are the result of shopping around and finding the best compromise I could find. So, yeah, maybe a longer shaft would help, but I'm not, ordering custom motors for this project, and I haven't seen something off the shelf that's better than the ones that I got for the price. And, I mean, I don't think that's really a severe limitation. I think having something where I have to couple this to another shaft is not necessarily bad. I think having some decoupling between the drive and the spool might actually be a good thing. So anyway, here's the gimbal. The current status is that the hardware modifications are pretty much done, and then I broke the parameters that are loaded on there. So that was in the process of learning more about the protocol, so I actually know some useful bits and pieces about how to communicate with this thing over serial now. We used a donated second gimbal to suck off some really fresh parameters that we could load in here, something that didn't have whatever I'd corrupted, and that got us most of the way there. Most of the yaw axis is still having trouble. The pitch, so the pitch and roll axes are fine, and that makes some amount of sense now that I think I understand the current problem better. So it's able to level the roll and the pitch just using the accelerometer in this last joint, but the yaw, finding the center position there relies on using a magnetic encoder in here, and that magnetic encoder, I don't think they have any way of manufacturing it with a consistent 0 position, Part of that comes from the variability in the sensor itself. So the actual chip doesn't have the same placement every time it's mounted. But then part of it, I think, is just the magnet. I don't think they have a good way of putting the magnet in the same angle orientation every time, so it probably changes. So I think they just have some per-device calibration that was very different between these two devices. And so when this one starts up using the calibration that I copied from the other working device, it causes this one to start homing to a position that seems like it's actually like right over there, kind of past the end stop on this device, which is not good. So there are a bunch of ways to proceed. It seemed like we might even be able to just guess which of the configuration values represented the yaw homing position. And so that actually might be one of the next steps. I think the first thing that I wanted to do was just to make a little tool that we can use to get a more real-time diff of the parameter space coming back, so that we can maybe get a current position from the magnetic sensor. And then maybe that would be really easy to correlate. Like maybe if we can see what the current position is, we can see like, oh, this lines up with the center that it's trying to get to. So yeah, I think that seems about right. Voice control. Oh, I'm just like going back in chat a little bit. It looks like Mikey is suggesting voice attack. Oh, I guess this is another thing for adding like commands to the stream. Yeah, I don't know how well voice recognition would work. I haven't tried like standalone voice recognition software in a while. I'm perfectly happy to have more buttons. I just need to kind of make decisions about where they should live and what they do, and actually build the hardware or find something that is a good value and buy it. So I think the next step is to just go back into our Raspberry and start doing some coding. Oh, there's still a bit of a cable monster down here. Here we are back in the terminal. Do we have a mouse? I have keyboard. Maybe the wireless mouse had lost itself. There we go. Okay, so our Raspberry is still going. This experiment is still pretty much where we left it. The Raspberry Pi is ready to run these little experiments that are written in Python, communicating with the gimbal over the serial port that's kind of hidden behind its PWM interface. And here we can see the previous experiment we did where we were just sending parameters. This is just echoing out all the packets going back and forth. We can also see the value that it reads back as it makes sure that the send worked, and then saving the parameters on each MCU. So I think I want to make a new script here. It'll be a little bit like this parameter dump that we have, which just lists out all the parameters, but I want to actually try something where it continuously scans and only prints out the differences, because I think that'll be helpful for identifying the sensors pretty quickly. So I think I'm going to go back to my tradition before of doing the editing locally over SSHFS, which I don't think I've mounted. This is a handy program if you ever find yourself needing to edit a bunch of files in your Raspberry Pi. You can mount its file system locally. You can also do it the other way around if you have files locally and you want to keep them safe on your local computer but let the Raspberry Pi access them. And it'll ask you for a login, but in this case I have an SSH key stored, so it can log in automatically. So there's the directory we've been in. So param dump, firmdiff is going to be the new one. So this is a module we've been using. Oh. There's actually a small improvement that I wanted to try. Oh man, Robert's already complaining about the file system. Doesn't matter. Yeah. I just don't even know what to say about that. Although I have an unrelated problem with this mouse, which is also annoying. Maybe let's steal the better mouse from the other computer. Oh, is this the right one? There are so many wireless dongles. Which one goes with which mouse? Oh, that's so much better. Okay, I'm going to ignore all the file system rants because I really don't have time to care about file systems right now. Right now we're talking about gimbals, folks. It's like you try to help someone out with a useful tip and someone's like, my pet thing is different than your tip, so there. And it's like, well, you're not wrong, but also no one cares. So I think let's just make another version of this. I actually don't really care about having... I was going to make a function that's like retrieve all values into a data structure and then diff those, but I think I'm just going to have two separate loops for this. So the initial values are going to start out as none. And then I want to retrieve initial values here. Oh, no. That's... Apparently, just my luck to have my keyboard lose connection while I'm holding down backspace. It's not even wireless. Yeah, I think there's something funky with the cabling over here that I just need to fix. The USB hub was dropping off. So, initial values, and then I just want to go into a loop polling these. Jeez, what is wrong with this? Something else on this bus having issues today? Just unplug everything else on this hub that I'm not using. I think that's an improvement. You know, I get really tired of the tongue-in-cheek trolling, because, like, it's still trolling. You know, it's not any better because you think it's funny. Like, that's usually how trolling works, is that people think it's funny. So, pretty basic. I just want to know when things change. If we weren't already going to see tons of logging from this, I would also want to print out, like, an indication when we have each cycle going on. But as it is, I think I actually want to make this a little easier to see given how much else is going to be going on. And I'll also probably want to be doing grepping for this later. So maybe I'll make that a little easier to grep for. So the script is just going to start logging everything we're doing into TypeScript, and we can chop it up later if we care. Param diff. So if we just run this to make sure it doesn't have any syntax errors or anything, it's just going to sit there waiting for a connection and timing out after 10 seconds. So yeah, so that's what we expected. This time I'm going to try that, but actually turn on the gimbal, and we should see the connection. And then it should start polling the gimbal for parameters. It'll end up rate limited by the speed that the gimbal replies at. So I don't think we're going to have to worry about overwhelming the gimbal's command queue or anything. It does seem to be susceptible to buffer overflows or something. But I think we'll be fine. Let's restart this too. Let's maybe make that a little bigger. All right. Get this set up for the right voltage. All right, here it goes. Param diff. So it looks connected. And now we're going to go into those change packets. So I think it's working so far. We're not going to really be able to see what this is, but I think now we should do another run, but filter the output differently. So I'm just going to delete this because I don't think I need the TypeScript. I think we can filter this a little differently. And then let's try param diff, and then just grep that for our change marker, and then also store that output somewhere. T is going to add a bunch of buffering, so maybe I'll use TypeScript again, actually, or script. That plus the line buffered option in grep should reduce the latency between when something actually gets printed out by our diff script and when we see it, so that I have a little bit of an easier time correlating it with moving the gimbal around. So, restart this again. Okay, so you can see a lot going on, and it obviously is not scanning it fast enough to keep up with all the changes. One thing we could try is to now that we kind of have an idea of what's changing, we could try only scanning those. It also might be worth, whoa, timeout. It also might be worth trying this and grepping it for just a single one of these n parameters at a time at this point. Or even having the script only pull a single one at a time. So, I mean, we can already start to guess which one of these might be interesting. The numbers that we care about are probably going to be kind of big and arbitrary because they're going to be readings from a sensor with probably like 12 or 16 bits of resolution. So something like, 6 is probably not it. And this is obviously like a version, probably. I don't know, obviously, but that's the same as our version. It probably isn't like the 24, but it might be like this, for example. Yeah, let's maybe focus on just one of these, like 28 perhaps. That seems like maybe a good one to try. So maybe let's actually just keep track of these ranges. So then the n range, in this case, would be just a single value. We said 2c, no, 28. But we can, now we can adjust those a little more easily. And I don't necessarily need to change that slots definition up there, since that'll just act as kind of an empty storage that we fill in as we need to. Alright, let's try this with the gimbal powered off. Okay, 2.8. Yeah, this is looking more like a sensor reading. I think maybe this might be even easier to deal with if we focused on one axis. Actually, it would be nice if this tool, anytime there was a change, if it prints out the entire vector. Maybe instead of just the single current value, I use that entire slot. This is looking better. So I'm trying to move just one axis. So it's like negative 19, positive 19, then like this one that's changing a whole bunch. So I think that's it. If that was the accelerometer, I would have seen changes in all the axes, but I think that's the magnetic sensor value. So that's the last axis changing from 5,000. Whoa. This is actually going through. This might be encoded in some other way. This might be more than a 16-bit number, and part of it might be elsewhere. Yeah, right there it rolls over. Yeah, this is probably more than 16 bits. Let's look at maybe what else is changing. I'll just set this back to the full range now that we have this like vector output format. Maybe it'll be a little easier to see what's going on. Hello, keyboard. And this USB hub must not be happy with me. We're still making a script, yeah. This would also be nice if I had like a graphical output for this. Maybe it's time to just start using end curses to splat these to the console in particular places. Would that be fun? Would that be a fun thing to do? That would kind of feel like an old mission control display or something. Just catching up in chat a little bit. Those magnetic sensors actually, this has come up in chat a couple times. The data sheet for those sensors, they're actually really interesting. I think I've got that handy. Yeah. So I think this is the angle sensor we're using in the gimbals. I think there's one of this in each axis. This uses the giant magnetorestrictive or resistive effect, which apparently is this really cool quantum thing that happens when you have alternating layers of magnetic and non-ferromagnetic conductors. It's pretty cool. But this little part, let's kill the overlay for now. Yeah, so there's actually a bunch of processing in here, and it can either emulate a different kind, like an optical sensor, basically, or you can talk to it over I2C, which is, I'm assuming, what they're doing here. So I think this just gives you an angle. After all of its internal processing happens. Or the register outputs. Actually, it would be nice to know what the output format is. So there's an XY amplitude for the GMR data. Has writable stuff. So you need to set up a status if it's emulating something, right? Hall switch mode. It can just emulate 3 separate Hall switches. That's interesting. Yeah, so these are all the different things it can emulate. Where's the register interface? Open drain, synchronous serial. There might be a separate document for this. Or I might just be missing it so far. Yeah, what are the commands? Read, write. I'm mostly just looking for the register table. Six-bit address. It's possible this isn't documented. That would be weird. More likely I'm just missing it. We might have one of these other variants though, like the incremental version. You'd think that they would want the absolute data, at least as much as the chip knows about it. Anyway. Oh, looks like Piotr's had good luck with doing something similar, just like splatting things on the screen with curses. Yeah, I think that's pretty much what I'm going to do. Oh, and Lavach says that we have the E1000 chip here. Which one was that? Okay, so that is incremental. So this is the version we have. Lavach remembers it, which I'd have to go check the footage. 12-bit mode, 1 count per 0.088 degrees. Okay. I don't know how it communicates the 0 state. Yeah, there's probably some other manual here, but the 12-bit output is kind of what I was looking for then. I don't know why we're getting this weird wraparound behavior then. But let's make this tool a little bit better. I want to use curses to display this stuff a little nicer. So let's look up some curses commands. Actually, I think there's a man page for this. Man console codes. This will tell you how to get the console to do interesting things. At least this is written for the Linux built-in console, but it applies to most terminal emulators. And so we're looking for move cursor mostly. We might also want to change colors, but I think this is what we want, the H escape here. Yeah, so I think the way that would work, we can experiment with this just using echo. /E stands in for the escape code itself. And I think the way these work is they start with an escape and then that open bracket and then an action like this. Oh, actually that's the final character, so I think we want the number to go before that. So I think if we did that, it would actually home the cursor and print yo. No? Did I do that wrong? Oh, maybe this doesn't have -E in its echo. Let's try this on the Raspberry. Oh, there we go. It moved way up there. That wasn't exactly 1, 1. What about 10, 10? That didn't work either. I don't think I'm using the right delimiter. Maybe it was semicolon? I think it's separated by semicolons. Let's try that. Yeah, that worked. So you can see it printed. Let me clear the screen a little bit. If I run that, you can see it moves the cursor to 10, 10, prints it. So this first number I think is the row, and the second was the column. Yeah, that's the same row. Okay, so let's just try using that in our Python script. So I think the way I want to do this is to leave some space on the screen to just, like, I think to basically dump the stuff I don't want elsewhere on the screen, and then to move the cursor to, you know, just well-defined locations for each of these changes I'm keeping track of. So I think I want okay, so each of these little displays on the screen is just going to have its number and then the entire vector for all 3 microcontrollers. And then as soon as I print that, I'm going to move the cursor back to some other location I don't care about. So maybe I'll make that the top left corner. And then I'm going to calculate that position. So row, column, I want them to be kind of in a grid since I don't have enough room for just one or the other. Oh, Ken is suggesting to use Python's built-in curses support. I guess I could. I've used curses so many times, I don't feel like using it again. I just don't. I mean, maybe Python's curses is better than libcurses itself. We could do this. This is another approach. I don't feel like doing this right now. Right now I feel like keeping this simple. But that would totally be another way of doing this. So what do I want this to look like? I think I want it to start somewhere around, like I want to leave a couple lines at the top of the screen, but then I think I want them to go left, right in like 2 columns. So maybe something like that. Let's see how successful that is, if any. Oops. That doesn't seem to be the right escape code thing. I think maybe \E does not do what I expect in Python. Oh yeah. I mean, I could do /x1b. I might need to make this ASCII, but I think the control codes aren't something that I have to worry about the encoding for just yet, but I could be wrong. Okay, that's kind of what I want, but there's just too much RxTX spam. I need to... I mean, the terminal has features I could use to put that in a window or something, but I think I'd rather just like silence it altogether. So maybe... Do I have a verbose option yet? I would like to keep track of verbosity level so that I can have this output be something I can easily turn on and off. Alright, let's just put it up here. And let's default to true, because most of the time I kind of want to know exactly what's going on. That's tempting to print out regardless, but... I can't quite tell what that blob of code in chat is, but I assume it's super important. Is that just a bunch more of what I'm doing here? I don't think this actually cares yet, but I might later, so I'll keep that around. Oops. Connected. Okay, I should have cleared the screen, but we can do that manually. And I might need more than 2 columns. Do we not have the printf parameters lined up? It's row and column. Oh. Yeah, this is supposed to be n. I decided I didn't care what the previous value was. Yay, we're getting telemetry. So that looks like another copy of the version, which changed over there. Now it's 1.15. Now this is going to be updating pretty slowly. You can see the updates trickle in. Whoa. And it times out, apparently. Can we increase that? Okay, you can kind of see the update rate. It's like about 1 hertz per component, so maybe the whole thing is being updated every few seconds. So a few of these definitely look like readings. So 2.8 was the one we were looking at before. Oh, I need to add a little bit of extra space at the end of these to clear the old value. I'm looking at that third value in the number at 2.8, which is where we were before, which is the one that seems like it should be the magnetic signal, but is maybe moving around more than I would expect and doesn't clearly go from place to place. What about 9? I mean, so maybe 28 is some processed value related to that. Maybe 9 is actually the magnetic signal. Let's look at how that moves. That's kind of nicer. I like 9. What about 6? Six is also moving in a similar way, I think. Oh no, 6 is just kind of jumping around a bit. That's not as useful. Okay, so that's been mostly the pitch axis, the axis number 2, the one on the right. I'm gonna try turning so I'm gonna leave that slack. And I'm gonna try turning the yaw axis, which should be 0, I think, so the one on the left. Ooh. So I'm seeing it increasing 3,000, 4,000, 5,000. So that hits about 15,000. Going the other way is negative 16,000. It's pretty good. Center position is like minus 500. So that's what we should have as the center. So maybe something near there is what's actually the center. What is it? So I'm going to try pointing it kind of over where it thinks it's been centering. And that's somewhere past 15,000. So maybe the location that it's, like the center that we're incorrectly using, copied from the other gimbal, might be a value slightly higher than 15,000. I'm curious what's over here in our splatted parameters that might correspond. I need to word wrap this. Maybe this one, the 25,000. That's a little higher than I expected, but that would be in the right ballpark. what we're looking for is a number between like 16,000 or so and some upper limit, which also seems to be in a cluster of numbers that seem to be like not round numbers and somewhat large, so something that is probably a measurement and not just an arbitrary thing that someone set. So a lot of these are pretty arbitrary. And like, you know, these aren't arbitrary, but I disqualify them because like this is 0, whereas I'm looking for a larger number. These are all pretty arbitrary looking. Those are all arbitrary. This is a round number in binary. This might be it. This 25,000 totally could be the center position. This is another kind of organic looking number, but not in the range we're looking for. This one is in the range we're looking for, but looks too, you know, arbitrary, like somebody just chose that number and it's the same on each axis, which is also kind of not a good sign for what we're looking for here. So I think that's going to be the number. That's the only candidate I'm seeing. So maybe what I do is, you know, we've got this saved in GitHub. I'm going to verify that, but what I might just try is changing that number to be more like what we're seeing here, which is the center I'm seeing here, assuming 9 is actually the magnetic encoder reading, then the center location I'm looking for is more like 500, maybe 800. Yeah, let's set it to like 800, 750, something around there. And let's see what that changes. So yeah, I've already made a change that I want to revert. Actually, I was playing with that version number to see if I could get it to reset the parameters automatically, but I'm going to stop doing that. So let's update that. And now I'm changing this one that is 25,205. Changing that to 750. I think that might be the thing we want. And so then the way this works is I run it once, it saves the parameters to EEPROM. Then I reset the gimbal without anything connected to the serial port, and I just watch it power on normally and see if that works. So this is not the most useful diff. I should really break this up. But if you look very carefully, you should be able to see the difference. Yeah, so this is 25,205, this is 750. Everything else is the same. Okay, parameters are saved. I unplug this, and I'm going to carefully hold this in case it's really cranky, but I'm going to power this on and we'll see how this does. Nope. That didn't seem to help. What else could it be? Oh, you know, I guess I wouldn't necessarily expect it to have similar values for axes 1 and 2, since the other axes might be automatically calibrated. Anyway, let's revert this. So this is back to our good set of parameters. Well, as good as we've got. So something else where 0 might have the wrong value, or axis 0 might be doing it wrong. And it did seem like that incorrect center location might be something like, I don't know, like this 18,000 up here. But that also doesn't seem like a value that would have been calibrated. You know, it would also be useful to have like some baseline values. Maybe I'll change this diff script to display the initial values too, but then just display changes in bold or something. Let's also clear the screen. J. So I think the color is going to be like it has like a series of mode attributes. Yeah, set graphics rendition commands. You might have seen these before if you've done like console like ANSI graphics. You set the colors. You can have a list of colors that you set. 0 resets things. And this is the only thing that cares about the columns now. And so so that'll just be whatever color codes, including none, like that can reset colors too. Then I'll also include a reset over here so I don't leave any colors set at the end. And then this will move the cursor, and that'll actually draw what we want. This will do. We could certainly tidy this up if we wanted to, but I don't really care right now. I think having fewer abstraction layers is probably better than making it look pretty on first inspection. So update initial values, and this can default to 0. And I think right now I'm just going to try bold. We can try other colors and things, but right now I'm just going to try bolding the ones that change and leaving them bold. So that'll set bold. Let's try that. All right, I still need to pad these strings out to an appropriate width, but that's getting much better. Got a bit of a mission control vibe already. How long do I need these to maybe be? Let's say 25. There we go. I know that's in the way a little bit. Let me move that. Okay, so that's the initial values, and then it just keeps scanning, and anything that changes ever gets set in bold, and so you can see the stuff that's at all dynamic. Some of it might have just set once when the gimbal was starting up. So like, all of these just seem to be 2. Maybe that's an orientation or an initialization status. These are small numbers. This is interesting, this number at 8. I think 4 is a difference in magnetic position. It's like if I spin this, those numbers kind of transiently change. Yeah, if I move this at a constant rate, that seems to read. Whereas this seems to be the actual position of that sensor. This seems to be the firmware version, but only after it's initialized. So maybe this is like an output from the initialization process. Maybe this is like the saved version of the configuration, whereas this is the updated version or something. This 18,000 could be part of the problem. Like that might be one of these numbers that is set wrong in this particular gimbal. And then as for distinguishing like per axis sensors versus IMU, like gyroscope or accelerometer sensors, I should be able to make movements on a single axis. You know, like this, I'm only moving the roll axis. And so something that's based on the magnetic sensors, I should see the, you know, I would see, for example, joint 1 change significantly and the other 2 hold still. Which I think if you look at, say, line 6, I think the middle number is changing and the other 2 shouldn't be moving much. I'm not doing a good job of holding the other axes super still, but I think the middle one's moving a lot more. Whereas you might see something else change in more than just a single axis, and that might actually be the accelerometer. Maybe 28? I'm wondering if 28 is related to the accelerometer. You know, I guess I could just hold the joints in the same position and tilt the entire thing. It's a little harder to do, but let me try to do that. Okay, so I'm trying to hold the joint steady. So if I look at 6, I'm not seeing that move much. Whereas my hypothesis is maybe like 28 is changing. I don't know. Mm, 48 maybe? .48 seems to be changing when I move this, but I don't know if it's the primary thing or like a secondary effect. Since I would expect maybe some of these to be internal state for the control loops, which would also change as it's trying to like theoretically track something. Oh, Ken Keeter is saying it's 09. Let me take a closer look at that. Whoa. Time out. Oh yeah, 9. That seems nice. Yeah, so that could totally be the sensor. I assume it'll be really useful to be able to query this stuff from the gimbal as it's operating. We won't get the most amazing data rate given this is only 115K, but yeah. Oh, and then Sodium noticed that 06 and 48 look similar. The values seem to be in about the same range and update similarly. Yeah. I wonder if those are just different, like slightly different versions of the same data. Okay, so this is all still very interesting. My main goal here is to figure out how to get the gimbal to notice the yaw 0 location that I'm hoping it will notice. So what we're looking for is something that is not bold, that has a value in the first position, like the left number, that we think we could change to maybe get a better yaw centering. .64 is an option, maybe 4D. Maybe those are the best candidates so far. 64. 64 and 4D. I mean, neither of those are in the range I was expecting them to be in, but maybe the centering works differently than I thought. also be 1B. It might be useful to see this in operation. I'm wondering if maybe the next step is to make a version of this which turns on the motors while it's doing this querying. Oh, interesting. Ken Keeter is noticing the first value of 9 seems to be incrementing, but then that might be gyro drift. Yeah, that seems gyroscopic. You'd also really think that it would notice, like, it has all this feedback. You'd think it would notice the end stops. .55 also looks interesting. It has a value only for axis 2. .6F is also changing down here all by its lonesome. Yeah, and so Paul points out the number we're looking for should be non-bold and different for each axis. That is potentially true. My theory is that maybe this number is only present on axis 0 and that it's automatically determined for the others, but I guess it would be written dynamically, so we should be seeing it here even if it wasn't in the... 06 seems to hold pretty steady when you're not touching it. Yeah, I mean, it looks like, I think we were deciding that 06 is probably the, we should be writing this stuff down, right? 06 is probably the magnetic encoder, and 09 is probably the, yeah, the gyro. So 06, I think, gyro. 09, or no, sorry, 09 was gyro. I'm getting these confused. And 06 is maybe the magnetic encoders. That last number in 6 is acting weird. Yeah, I wonder if that's like a problem with like split 8-bit reads or something, so when I'm moving it quickly, it gives me bad results. I don't know, you see that jump? It just went from like minus 1600 to 300. Oh, sodium's just maybe the values at 48 are raw encoder data and 6 is filtered. What a float. Surely you must be joking. Trying to spin the yaw axis really slowly. seeing 6 respond super consistently. Yeah, I don't know where the encoders are right now. That I'm not getting data that makes sense to me right now. Got a chunk of iron floating around that you could bring near the gimbal. Well, or an actual magnet. Yeah, I mean, I've got plenty of things with magnets on them. Here's a remote control with a magnet on it. "28 is doing a massive rollover with yaw." Yeah, that's what I was just looking at. But both 28 and 6. I'm trying to just turn things slowly and try to restart this. Hello, keyboard. Really? Oh, that's not the order to plug those in. There we go. That's what we got again. It stopped updating already, didn't it? That just seems like it's all over the place. I wonder if there's some initialization step it's missing when I don't actually turn on the feedback. Okay, so I'm just going to try getting a magnet close to the yaw axis. That definitely changed the result from 6. And yeah, that's axis 2 on 6 still. Axis 1. 6 is definitely related to the magnetic encoders. I mean, probably several of the other ones are. I just can only really pay attention to one at a time. Start annotating some of this. So magnetic sensors probably at 6. Man, there's so many of these that seem... I just don't know what changed, because I thought we had this in a state before where it looked like I was getting a pretty good full range out of at least the magnetic sensors I was looking at. And now this just seems super erratic. Oh yeah, 4 definitely does look like velocities, huh? Dr. Toon says, if it was me, I'd be plotting all these as 1D or 2D points or vectors, way more visual. Yeah, sure. That's just like, we just wrote this code. I'd love to keep adding stuff to it. It's just curses seemed like the next thing to try. Yeah, but having a separate dot for each of these totally could be useful. And yeah, maybe pygame. I'm not even really sure that this is the right encoding though. Like, these might not be signed 16-bit numbers. Yeah, so it looks like 4 is the angular velocity, and then 9 is gyro angle. But I mean, I'm part of me is like writing this stuff down as we find it, but I'm not entirely set on going in this direction, because mostly I just want to find the yaw position and set that. You know, it's also possible that some of these that are related to the magnet are x and y, and some of them are angle. I'm looking at 4C right now, and wondering if that's going to keep correlating with the angle. Not quite. That might be... So some of these might be like the x and y outputs from the angle sensor. I think it might be time to switch back to like a hexadecimal encoding or something. Why do I have two 28s here? How did I mess something up so that I have the wrong numbering? That seems like a problem. I guess that was actually pretty useful, having the DSLR up. Okay, so 9 and 4 are IME related. 6 is magnetic related, but kind of weird. I don't know what to make of that. Magnetic unknown. So then 2, 8, and 2C. Oh, maybe 2C is my angle. Is that what I'm missing? So far, the correlation is perfect. I just stopped again. Yeah, 2C, I think that's going to be the angle. Cooked angles. So then I think that's the coordinate, like this is kind of the type of, like, I would expect the numbers we're looking for to have about the same scale and coordinates, like coordinates as, units as these values, which are probably processed by the angle sensor chip we were just looking at. So then 2, 8 might be something related to that, like one of the two axes, or it just goes up and down a lot as I rotate that axis, so that would require closer investigation, maybe graphing it. I mean, I like Dr. Toon's idea of like throwing all of this in Pygame or something. I just don't think I'm quite ready for that yet. I would maybe expect the parameter I'm looking for to be close to here. But yeah, I think we are looking for something different on each axis and not bold. I mean, probably not something like 5A. Have something that's, because I think we're going to see a bunch of parameters also that are 0 everywhere except the last axis, which is where we have, I think, some more coordinated part of the algorithm. 64 seems maybe likely. So where's the center that we're looking for? 4C. That's 13,000. Or sorry, not 4C, 2C. Yeah, these, I'm curious what those are. So it's like 300 over there. It's like 2,000 in the middle. It goes up to like 3,600, no, almost 4,000. So like if that's the coordinate system, the place it was aiming at would have been, like a small number. Like maybe 0? Are we looking for a 0? Maybe we're looking for something with a 0 or another small number in axis 0, and then something non-zero in the other two slots. I don't see anything that fits that. And we could just start trying more things, in terms of trying to set more parameters to different values. We can also try to get this program operating with the motor controllers on. Oh, interesting. Sodium says 8 only changes when you move it to the extremes. Oh yeah, I don't see 8 changing at all now. So 8 is actually one that we see the Windows software write to. Also, this seems to be the on-off switch for the control loop. Or at least something like that. 6, 7. Kind of curious what 6F is down here. These just kind of meander up and down a little bit. Mako MK is suggesting setting 6.4. Oh, interesting. I think is that the value that we had from before, like splatting the new settings on here? 924 or 1940. Yeah, let's change just axis 0 in 6.4 and just see if that has any effect. Um, 6.4 is 1696. And we want to change that to 924. Yeah. I guess we might as well set this other one. Thanks for the numbers. This is from an earlier video, saving us the lookup. This is in another little space that might be configuration, huh? Near the end. Oh, these diffs are terrible. I really should break this up with lines. Anyway, let's just run that. Dangerously splat. Oh, and also there's a good suggestion that 08 might be related to the angle when it's powered on, or some representation of the like quadcopter host angle. That's a good point. I also don't know which of these might be not updating because the control loop is turned off. Alright, I'm gonna write these parameters. Okay. And let's see how it is. I think that made it worse. Let's try it again. Wow. We did change the center location. It just didn't really change for the better. So it seems like this axis is now totally wrong, which is axis 1. But maybe we're in the right location. So what did we just change that between? Oh, this view is terrible. I really need to break this up. Anyway, so we changed this from 1696-2174 to 924, 1940. It feels like the yaw location didn't really get better, like it's now wrong in the other direction. So maybe I'll just try setting this to something in between, like 1200, and then leaving the second value the same. 2174 is the one we got from the working gimbal that seemed to be okay so far. Okay, so this is the number we care about, the 1696-2174. I'm going to set 1200-2174 and leave the other two. Let's just try that. Okay. Okay, now it's back to the position that's kind of way over there. I mean, I thought the number that was going to be right was going to be like around 800. So we could try that. Oh, nice. Dr. Toon has some quick Pygame code that might help out. And it looks like Ken has a suggestion to try diffing with color for individual words. Let's try that. Is that what I'm reading? Color dash words equals dot? Interesting. What does the dot do, and why are these so mashed together? I guess I see what it's doing. That's kind of neat. It's just at a character level. Oh, gotcha. So I guess normally this breaks it up word by word, but this is telling it to break it up character by character, since dot is a regex that matches a single character. That's neat. Very useful. So, yeah, let's avoid getting too distracted. Let's try 800. I want to try 800 and see where that takes us. Whoa, different problem. Huh. Well, it's still kind of confused. It feels like there's a point in the middle where it like rolls over and doesn't quite know where it is. It's acting like the magnet's on there backwards or something, but I didn't take the magnet apart. The other axes are fine. The other axes are stable. I think it might be time to do a live dump with the motor controller on, though. Yeah, it's hard to tell what of this is it working partially and what of it is like error recovery behavior. Let me try continuing to change it. I think we're at least changing the right thing. I guess I'll just bump it to 400 and see what that does. I'm still not quite sure what coordinate system I'm dealing with. Oh yeah, that cat has a suggestion that maybe that value is a control loop parameter and rather than just a center, so maybe I'm making it unstable. That's certainly possible. Yeah, that made it worse. Well, maybe this is a good time to go back to Jupyter notebooks and make something that I can use to interactively tune this, since I think I've got a better starting point now. Let's maybe set this back to 800 since that's the least violent value that I've seen so far. Maybe let's try 1000. I think I was going in the wrong direction, but let's see if this is any better. So I might just make a brief attempt to improve this in the current state, but I think the next step is to interactively tune this, maybe with the Jupyter notebook thing we were using. Negative 800? I don't know if it works like that. I don't know. I didn't get the sense that 0 is relevant in this system, but I don't know. I guess we could try that. Yeah, that's worse. Oh, we could try a 0. Oh, Michaela just joined chat. That seems like a good time for a recap. Yeah, so the gimbal, they're asking if the gimbal is happier. Well, the gimbal, I don't know if the gimbal's happier. I'm happier. So I think we're on the way to making the gimbal happier. We have a better idea of what this is doing. I think we found at least one of the parameters that contributes to the behavior of this part of the control loop. And this has kind of been a combination of trying to find parameters that are stable enough we can just get it running so that I can use that as a basis for tweaking it further. And some of this has been actually trying to figure out what the parameters are. But right now it's pretty annoying to mess with the parameters, so I would prefer to get the gimbal working and then to mess with them from there. Alright, I'm going to try negative 800. So this is a parameter. So we know more about the parameters now. It has a space of 128 16-bit values in each of the 3 microcontrollers, which are per axis. So the way this is set, it's just a list from 0 here to 127 here, and we have these vectors. Each one is a tuple of these 3 microcontrollers. So it would be the yaw microcontroller, the yaw, roll, and pitch microcontrollers, just like in the order that you would go down the arm. And so this is a process that takes all these parameters and splats them into the gimbal. And this is mostly based on just reading the parameters out of a brand new gimbal, which is working correctly. But the main hiccup seems to be that there's some per device calibration that we don't have, and so we need to figure out how to recreate that. Oh yeah, so the other parameter that Paul pointed out to tweak is 4D. Yeah, man, I really need this to be labeled. I have to correlate this back to each individual thing that I'm changing. Oh, my keyboard is not working again. Why? I'm just having a USB hub related data integrity problem today. Yeah. So let's make this a little more organized. I think I want that, but with trailing commas. Oops, not on the comment. So I would actually like to do one commit that just reformats this without changing the values, just so I can keep my sanity, whatever of it that I have. So the parameter we were messing with was this one, 2648. It's a little nicer. Okay. So now, 4D is the number that Mako MK was suggesting we take a look at. Yeah, so this is, I was looking at this one too, I just didn't know what the number was. And did we look at 4.8 already? That could be it. Let's try that, see what happens. So just 4.8. Diff is so much easier to read now. Let's commit this to... Oh, 48 changes. Gotcha. Appreciate everybody out there who has enough spare hands to take notes while the stream's going on. Alright, there goes nothing. It feels similar. It's hard to tell whether it's maybe swinging a little less violently. It seems similar, though. See, when I grab it and keep it from moving, it's less likely to damage the mechanical parts, but it's more likely to heat up the electrical parts because it's just going to run the motor. Oh, did I hit 48 instead of 4D? Oh, I did. Sorry. Okay, 4D, 800. Let's see what that does. Okay. Oh, it is definitely trying to point a different direction now. It is swinging against the other side, and Yeah. It looked like it wasn't even quite going to hit the end stop, but it was. Okay. Well, that's cool. So that completely changed what side it's trying to hit. What if we go for something in between? Maybe 1600? That was multiple cursors, which wasn't what I wanted. Oh yeah, and then so MakeOMK, it was also suggesting a value from pre-tinkering on the gimbal. That was, okay, so what do we have right now? We start out with 2943, and then the pre-tinkering value is 212030. That's, I guess we could try that. That doesn't seem like as big of a difference as I was expecting, but 2121. And then like 3812, sure. Minus 800. Yeah, we could try minus 800 next. It's still... Oh, now it's like holding up against that side without bouncing. It definitely feels like the control loop is like springing that way, like it pushes harder when I push it further away. Cool. Minus 800. I'd like to have a tool to change this at runtime, though. I think we might just want to do that next, so we don't have to keep thrashing the flash memory. Have I tried 42? That's a good question. That's minus 800. That's something I can live with. I think there are other parameter problems here. But it is no longer thrashing. It's just wobbling now. It's like a washing machine. You know, if we plugged in the camera feed, it'd probably be really annoying right now. I think we might have to do that just for fun. Let's take a look at the camera feed. I'm just going to grab a random SDI cable for this. It's a little out of focus. Yeah. I don't think I'm going to bother getting it in focus, but at least it's smooth. It doesn't have crazy wobble. It's the no bot, yeah. Is it stabilizing? Looks like it. Yeah, it's stabilizing, it's just constantly disapproving. You know, I wonder if this is something about the follow rate being set to a weird value. I don't know. Mikkel suggests adding an overlay that says looking for target. Yeah, I mean, this definitely looks like a control loop parameter is just not at all set correctly. But this seems to be maybe a workable starting point for making a little parameter tuning UI for ourselves. So let's keep that from just flexing the cables unnecessarily. Back to our regularly scheduled cat butt. Oh, Mikkel says the stream died? Is anyone else having trouble with the stream? My YouTube status still says it's alright. Or is this a joke that went right over my head? Alright, so I think the next step here is to kind of poke at this Jupyter notebook and try to get a sense for what these different parameters do by tweaking them a little bit. So, I don't know if we need that script. So let's save this. Okay, let's see, where do we go next? I feel like I could use a bit of a break here. Maybe what I should try to do is, instead of making this like one super epically long stream, I should try to take a break, and it's probably a good time to eat dinner here in this time zone, but maybe regroup a little bit and then come back here maybe with some UI for tweaking these parameters. Since I think there's going to be a little bit of just boring stuff in getting that set up, but I think the next step is to have a way of interactively messing with the parameters while the gimbal's running. So I think I'll do a few of the chores and getting that set up, and then that's probably what the next stream is going to be about. So if anybody wants to play along at home, all of the stuff we've been doing so far, well, I was about to lie if I don't actually push this. So I think at this point, if you actually go on GitHub, you can find what we've been doing. Scanlime/Feiyu Gimbal. In case you feel like playing along at home, it has SIGROC decoders, some traces that we've collected so far, mostly SIGROC traces and parameters, and then the little scripts we've been doing. MakeOMK suggests if I'm really lucky, changing 4D to 2121 and 64 to 924 might work, but a break might be a good idea anyway. Yeah, well, okay, we can try that. I mean, I feel like I'm a little low on ability to plan ahead myself, but if you have a suggestion, I can just like type them in and try it. So I still have some energy for that, so sure, we can give this a shot. See if we're lucky. Oh look, card's full. That's also a reason to take a break, maybe. Although, if this works, I kind of want that on a card, so let's actually get one ready. Card. Come on, menu. Camera's nice and toasty. Okay. So 4D to 2121. Yeah, so maybe these are linked parameters and there's like a gain and a center location, or, you know, two parameters for the same linear equation or something. 4D to 2121. 64 to 924. We can give that a shot. See if we're feeling lucky. So that's what we got. Got some parameters saved. And let's gently power this on again. Whoa! It's less happy than before. I tried shooting an email to the company that made the gimbal. No, I haven't. I really don't like email. If you like email more than I do, you're welcome to try it. I mean, I feel like there's reports all over the place of people having this problem, or like a similar problem on consumer gimbals, and I don't know if they have a good solution to that, so I wouldn't really expect help given that I've modified this gimbal so much. Let's make sure we can get back to a point where this is calm, since I think what I would like to do on the next stream is have this set with some fairly calm but incorrect parameters, and then to actually go and figure out what they do with some more graphical tools, whatever that might be. So I think that'll require a little bit of in-between stream work that is less interesting to get that prepared, have some tools ready. Another guess to minus 400. Well, so this will be a control experiment, just seeing if I'm back to the relatively calm parameters. And do you want me to try minus 400 for which parameter? Just yeah, do you want minus 400 just for 4D? Which is where we have, is that where we have 800 now? There's just numbers coming at me in chat. Where do you want me to put this one? So like I figure, okay, so 1696. So yeah, you're telling me 4D set to minus 400. So my intuition then is that this is going to be the center and that this is going to be like a gain or something, but okay, so 1696 there, minus 400. We're just making a small change here. I guess this will tell us whether it's a center or a gain. Because right now with minus 800, this is the behavior we've got, this like gentle sway. So then we'll try changing this to minus 400 and see what's different. That's an improvement. The motion looks similar, but I think the center location is improved. So that's nice. Oh yeah, and the roll axis is seeming to be stabilized pretty well. Well, that's great. We can power it on and it doesn't gimbal, or it doesn't want to break itself right away. It just wants to like wobble. Could it be the amount of force applied? I think that's more likely the center rather than the force, but I think we're at a good position though. Like, this is no longer trying to break itself. We can power this thing on and run it for short amounts of time without it being an immediate hazard to its longevity. So I think that's a good spot to be in. I think now I just need to make some slightly better tooling for poking at these parameters. I'm going to try doing this with Jupyter notebooks and see if that works. If not, I might just do something with SDL and WebSockets or something. But yeah. Yeah, center location is definitely improved. I think it's an unsigned value. Yeah, it could be. Some of these might have offsets. What is Mikkel saying? Please no to? Alright, well that's what we've got so far. Let's take a note around this too. So something like that. That seems like an alright stopping point for this particular investigation. Yeah, I agree with what Sodium is saying. So Sodium says, based on the change we just saw, 4D seems like it is or very closely related to the center location. Yeah, I think so. We could also probably go ahead and add that to this info text file here. So 4D. And I don't know entirely what unit, but that's probably related to the magnetic encoder angle units. Okay. And maybe 64 is a gain? Yeah, I could see that being... Well, this is an interesting... Yeah, these could be gains, huh? I wonder if we could just turn this number down. Like, 400 seemed like it was close, but not quite right on. Maybe if we set this to... I don't know, like minus 200 or 100 or something. And then... What if we turn this down? And what if we turn it a lot down, like 1200? Oh yeah, we tried decreasing it, and then that, yeah, as that cat was saying. Version number, slap it in there. Yeah, definitely. We should just throw the version number everywhere. We just have a script that brute forces setting everything to 0, FF, and the version number. Yeah, it's been fun poking around in the parameter space of this gimbal, but it'll also be nice just to have it working, I think. I'm looking forward to making it stable so that I can actually try sending the parameter. So part of the reason for this is I wanted to try sending it a packet that would command it instead of having to send pulse width modulation. And so I think I know how to do that now. I just haven't really been able to try it because the gimbal's been doing its own thing so much. $64 and 900 was violent. Maybe increase it. I think I'm going to save that experiment for when we have a nicer tweaking tool. Yeah, I think some more interaction would help with this experiment. So, I think I'm going to wrap up this stream in a sec, but we'll come back soon. If I have something interesting, maybe later today, if not tomorrow. You know, as usual, I stream when things are interesting, but try to make it pretty frequently. So thanks everybody for joining in and helping out. Oh yeah, Mikkel suggests that maybe that's a damping instead of a gain. That certainly could help out too. Yeah, I think so. Having a graphical tool to tweak these values is going to help out quite a bit. And as usual, if you want to check out the Tuco view in between streams, even though I don't have the flyer robot, you can go to twitch.tv/TucoFlyer and still see my not so flying Tuco camera. Right now, it'll just be cat on rack. Well, thanks for tuning in, everyone. Until next time.